things I want us to do today is to finish what we were talking about when it came to arguments. Now, there's no way that I can give you a crash course in logic, in a day and a half or whatever. But we've talked about statements and different kinds of statements and the truth conditions for different kinds of statements. And we are going to definitely talk about that again later. But at least I wanted to introduce it to you. Because we're going to be talking about conditional statements and laws and counterfactual conditionals and the conditions that must be met in order for something to be a law and all that stuff. So we're going to get to that. So at least I've exposed you to that. But in the end, you can't have an argument without statements, because the conclusion of the argument is going to be a statement. The reasons that are given in order to show that the conclusion is true, those are going to be statements. So you need to be able to recognize arguments when you encounter them. So I went over some useful things to know to recognize an argument and then write them in standard form. You'll be seeing some arguments expressed in standard form, so that's going to be useful for you to do. And then we started last class talking about how to evaluate an argument. And again, I just said this, but I can't teach you everything you need to know like in a day, right? So I can give you some helpful stuff that will enable you to become a better evaluator in the absence of actually taking a logic class, but there's really no substitute for a logic class. And here's the bottom line, that in order for an argument to be good, it can't violate any of the principles of good reasoning that apply to arguments. What this rule, called the refute rule, summarizes are all of the principles of good reasoning that apply to arguments. So, in the end, in order for an argument to be good in the fullest sense of the word, it needs to be cogent. And in order to be cogent, it needs to accord with all of the principles of good reason that apply to arguments. If it doesn't do that, then it's fallacious. So every argument's either cogent or fallacious. So in the end, in order for an argument to be good in the full sense of the word, it needs to be cogent. And for an argument to be cogent, the evidence offered in support of the claim must be relevant to the claim logically, because irrelevant evidence is bad evidence. It must be independent of the claim, otherwise it begs the question, and that's bad. You're assuming the truth of the very thing you're trying to show to be true. It needs to be free of dubious assumptions, as you saw last class. It can't be free of assumptions, because you can't make a statement about the world without assuming certain things. You can't ask questions to someone without assuming certain things. Of course, questions make crappy reasons, so you don't use those in your arguments because they don't have truth values. But you can't have an argument without assumptions. The one statement you're trying to show to be true when you argue is the conclusion, is the claim. In order to do that, you need to assume certain statements as evidence. There's nothing wrong with making assumptions. But not all assumptions are equal. And what we were doing last class, at the end of class, was reviewing, in the case of some of you, but presenting for the case of the other of you, all of the ways in which an assumption can be dubious for reasons other than, say, simply being false. So I'll revisit a couple of those here in a second. So the evidence needs to be free of dubious assumptions. It just can't be free of assumptions. The evidence needs to be unambiguous, otherwise it commits a fallacy of ambiguity. And the evidence needs to be true. Above all, false evidence is bad evidence, period. So what this rule summarizes are all of the principles of good reasoning that apply to arguments. Okay? So in a richer, fuller class where we cover this material over the course of a couple of weeks, right, you get it. I can't do that. I give you the material, but at least I want to equip you with some useful things to know. So you know that in the end, in order for an argument to be cogent, it mustn't violate any of the principles of good reasoning that apply to arguments. One of them is related to this. That is the evidence free of dubious assumptions? Again, you can't have an argument without assumptions. But one way, or put it another way, that there are various ways in which an assumption can be rendered dubious. That is something that's both unproven and unreasonable. And what the fallacies of presumption do are identify reasons that make an assumption dubious. So whenever you commit a fallacy of presumption, you'll always be able to identify something unreasonable that's dubiously being assumed. And that will be part of the reason or the evidence that's being given in order to support the claim. So you'll have to identify it. So I went through these last class. Accident occurs. And again, I'm mentioning this in the context of a philosophy of science class because we're going to be talking about particular cases and forming general rules that apply over all the particulars in that particular class, right? And there are ways in which the reasoning can go awry when you do that. One way is when you argue from a general rule, but you apply it to a particular atypical case that where the rule doesn't apply. It's unreasonable to insist that rules always be followed. As is the case when, the sign says no swimming, hence it will be wrong to go swimming even to save the child's life. You're dubiously assuming that rules must never be broken, even in the case of saving someone's life, right? So accident is one way. Another way that we encounter in science is through hasty generalizations. That is, when you consider only the atypical case, then you form an unqualified generalization on the basis of the small sample or the atypical case, you're committing what's called a hasty generalization. It's like, you go to Europe, you meet a Finnish person who is really, really rude to you, and then you generalize that all Finnish people are rude? Hasty generalization, right? And I've been to Finland several times. They are not rude. They're a rather somber bunch who drink a lot of vodka. I like the drinking vodka bit. Complex question we talked about. Composition and division. Think about it. Just because something's true of the whole does not mean it's going to be true of the parts. Just because something's true of the parts does not mean it's going to be true of the whole. So when you assume that what's true of the whole is true of the parts, that's a dubious assumption, and you've committed the fallacy called division. When you assume that what's true of the parts is true of the whole, you've committed a dubious assumption, and that fallacy is called composition. You have the book as a convenient way of refreshing your memory for these various fallacies of presumption. The false dilemma occurs when you force your audience to choose between limited alternatives when in fact more alternatives exist. And that's always bad. Another name for that's the black and white fallacy. And I'm focusing here on a false cause because in the end science is in the business of explaining why the world is the way it is and predicting how it's going to be in the future, as well as telling us what exists, right? So false cause often occurs in explanations of things. So basically false cause occurs anytime someone attributes the cause of something that isn't the cause of it. Now, it sort of sounds like you're begging the question that you know what the cause of something is, but the idea is that it doesn't follow that something's the cause of something just because it happened prior to it, right? So the fact that something occurred prior to something else doesn't mean that that prior thing was the cause of it. That's one version of false cause. Like, because Grandma listened to Howard Stern before her operation and she survived, listening to Howard Stern saved Grandma's life. No, false cause. Don't worry about the Latin names. Another kind of false cause occurs when two things are constantly conjoined with one another, that they occur at the same time. You attribute that ones that must be the cause of the other because they always coexist. So if A always occurs when B occurs, then A is the cause of B. No, it doesn't follow that A is the cause of B. The example I gave last class had to do with an increase in crime. So an increase in crime always occurs during an increase in snow cone sales. Therefore, an increase in snow cone sales causes an increase in crime. No. The crime occurs not because of an increase in snow cone sales, but because of the increase in heat, which is what gives rise to the increase in snow cone sales. The final version of false cause occurs when you simply attribute something as the cause of something when it in fact is not the cause of it. This is just sort of the catch-all. But this allows us to say precisely why certain conditional statements are unreasonable or dubious. Because although any two statements can be conjoined in the form of an if-then statement, that doesn't mean the resulting conditional is going to be reasonable. And I tend to use the same examples in this case. Sophie is a cat on the one hand. God exists on the other. If Sophie's a cat, then God exists is a conditional statement. If God exists, then Sophie's a cat. If God exists, then the moon is not made of green cheese. If Sophie's a cat, the moon is not made of green cheese. I can create conditional statements at will by conjoining any two statements. But this if-then relation is supposed to capture something that the two statements sort of have in common. Typically, it's going to be a kind of causal relation. But what's wrong with this argument here in number 5? If Homer Simpson isn't president of the United States, then pigs cannot fly. Homer Simpson isn't president of the United States, therefore pigs cannot fly. That's a valid argument, but I don't think we want to say it's a good argument, even though the claim follows from the evidence. And the reason is, what possible causal or other relation exists between a cartoon character being president and the flying abilities or non-flying abilities of pigs? None whatsoever. To assume that is dubious. So the dubious assumption here is that if pigs can fly, then Homer Simpson is president of the United States. I mean, that's unreasonable. So although any two statements can be conjoined, into a conditional statement, that doesn't mean the resulting statement is going to be reasonable or would be good evidence in an argument where you're trying to explain something. The final kind of fallacy that I wanted to introduce you to are fallacies where they violate what's called the R in the refute rule. And there are various ways that this can occur, but the name for these fallacies of relevance are called non sequiturs. Non sequitur means non-follower. So when these occur in an argument, it means that the conclusion does not follow from the premises. And the cardinal principle of good reasoning is that the truth of the claim needs to follow from the truth of the evidence. I mean, no argument in the universe stands a chance of being good if that principle is violated. Now, every invalid argument in the universe violates the R in the refute rule because the claim does not follow from the evidence. But in the absence of taking formal logic, you don't know how to tell for sure whether a claim follows from the evidence, that is, whether an argument's valid. So I can't ask that of you, but I can expose you to a few non sequiturs in order for you to be able to say, at least informally, that that's a bad argument and here's the reason why. So when a non sequitur occurs, and you can only tell when a non sequitur occurs when the argument's expressed in English. When the non sequitur occurs, the argument's bad because it violates the principle that says the evidence needs to be logically relevant to the claim. And that doesn't happen when the evidence contains a non sequitur. That is, when the claim does not follow from the evidence. That's what non sequitur means. So just so you know, whenever you attack an individual for the argument that they give or the reasons they give for their claim, and not the reasons that they give for their claim, you're committing an ad hominem, an argument directed to the man, but to the individual, and that's always bad. You don't like what someone says, you attack them. That's always wrong. People do it all the time, but it's always wrong. It's logically impermissible. Another way in which one can commit a non sequitur is to try to whip up the emotions of the audience to get them to accept a conclusion that isn't really being supported by the evidence. So when people use emotionally charged language in order to typically whip up the audience who's already going to accept their conclusion anyway, you're committing what's called an ad populum. Or when you say that, well, we ought to do this or believe this just because lots of other people do it or believe it, that's another version of ad populum. They're both bad. It is, the evidence isn't logically relevant to the claim. I'm skipping through these. You're not going to see lots of appeals to force or appeals to ignorance. It's impossible to go to the store and not see examples of celebrities or movie stars or sports figures, at least through advertisements in magazines and whatnot, hawking something, right? Well, if so-and-so uses it, then you should use it too. Well, that never follows. It doesn't follow that it's good or that we ought to buy it just because some movie star says it is. That's an appeal to inappropriate authority. We're not going to see appeals to pity here so much. This is worth noting. It doesn't follow that something's good or bad just because it's new. That's appeal to novelty. It doesn't follow. It doesn't follow that something's good or bad just because it's old either. That's appeal to tradition. That's a non sequitur. I'm skipping through the genetic fallacy, and I wanted to talk about a couple of these metaphor-driven ones. Red herring is one that you ought to know. Now, the name red herring as a non sequitur gets its name from the practice of hunting foxes in England. And what would happen is the lords would be on their horses. The serfs are out driving the hounds who are chasing the fox. Now, in order to prolong the fox hunt, what the serfs would do would be to literally drag smelly dead red herrings along the trail over the fox in order to divert the attention of the hounds away from the fox instead of killing the fox or treating the fox, right? Diverting the attention away. Well, red herring in an argument occurs when someone deliberately introduces an irrelevant issue into the discussion in order to divert attention away from what's really at issue. And this can occur in a variety of different ways. I guarantee you've encountered something like this before. Pat says, "You said you would be home by 10. It's 12. Why are you late?" Well, that's the issue, right? What does Carol say? Why was I late? Well, last night you said you'd be home by 6, but you did not return until 7:15. Why were you late? That's irrelevant to the issue. In any event, anytime you try to introduce an irrelevant issue in order to divert attention away from its related issue, that's a red herring. Straw man is an important fallacy to know. And again, it's a relevance-related error in reasoning. And think about it. At least when I was in high school, I don't know if they still do this. You'd go to the big bonfire rally, before the big game, and you'd have an effigy of an opposing player that you'd burn or you'd do something naughty to it, right? A straw man, right? The idea here is that your opponent's position is such and such. But instead of characterizing your opponent's position the way that it actually is, you exaggerate it, distort it, misrepresent your opponent's position, and then attack the distorted, misrepresented version, show that it's wrong, and then think somehow you've undermined your opponent's actual position. That's called a straw man. That's always bad. If the theory of evolution were correct, then humans must have emerged from the primordial ooze. Humans have nothing in common with mud. Thus, it is absurd to claim that we evolved. Therefore, the theory of evolution is false. Would be a straw man, because there's nothing in the theory of evolution that commits us to the notion that humans emerged fully formed from the primordial ooze. That's a straw man. It's a gross mischaracterization of what the theory is. But the thing is, it's often easier to attack distorted, misrepresented versions of things. That much is true, but there is, as I've told you, probably no other discipline that's devoted to the rigorous, fair, and accurate reconstruction of views with which folks disagree. And that's important, because you don't want in your essays for me, for instance, to mischaracterize your opponent's position when you reconstruct your argument and then attack this mischaracterized version and think that somehow you've undermined your opponent's position. You haven't done that. In fact, you will be guilty of a fallacy, and that will be bad. So avoid that. Another fallacy that we encounter a lot in the context of science happens to be slippery slope. There are other contexts where it occurs too, usually in moral context. But slippery slope is another metaphor-driven fallacy, and the idea is this, that you can imagine yourself walking on the levee here behind you, and it's raining. I've done this myself, because I used to park on the other side of the levee in order to save whatever that parking fee is per year, right? So I'd park on the other side of the levee, walk over the levee. I even have my white little waiter shrimp boots to put on those occasions when it's all flooded, right? I'd shimmy through the fence in the back, and I'd save myself $100 a year, whatever. Now that I'm chair, of course, I have to be here all the friggin' time, so I sucked it up and I bought a parking ticket. But there was a time when I'm walking on the berm, it's raining, it's slippery, and you sort of lose your footing, and you're just sort of sliding down the rest of the levee. Well, the idea here is this. With slippery slope, that once you start down that path, you're going to lose your footing and ultimately come crashing down to some undesirable consequence. So the idea is that if we do this, it's going to lead to this and this and this, and we don't want those things to happen, therefore we shouldn't do that first thing. So for instance, if this gun control legislation passes, then so will the next bit of legislation, and then the next. Before you know it, owning guns will be illegal, and government agents will come knocking on your door in the middle of the night to seize the family shotgun. If euthanasia were legal, then children will start killing their parents as soon as they retire. That would be horrible, hence euthanasia should remain legal. You get the idea. Irrelevant conclusion is simply a catch-all, because every invalid argument in the universe is an argument whose evidence is not relevant to the truth of the claim. But we have, in fact, a lot more named fallacies than the ones that I present in my book. In fact, we could have just a course on informal logic and name fallacies. They're that common. And the reason we have names for them is because people do find them psychologically persuasive. Some people are often surprised to hear that, for instance, ad hominem is a fallacy. I mean, because it occurs so often, or that slippery slope is a fallacy. But they are fallacies, and fallacies are errors in reasoning. So I can't teach you everything you need to know about logic and evaluating arguments. It's not the point. The point is to give you some of the tools and concepts that you'll need in order to better deal with the things that we're going to be covering in this class. So there are lots of examples where you can apply, that is in terms of the exercise items, you can apply your knowledge of these things. But I've got other things I got to do. So as imperfect as this little introduction was, I'm just letting you know, there are some standards that apply to arguments. You learn what those standards are in logic, as well as methods for assessing whether any of these standards or principles are violated. So there's no real substitute for a class in logic. what I had on our plates for today had to do with the scientific method. And the piece that I wanted you to read was something, that's awfully big, hold on, about zoom out to say, it's a little better. Still looks like crap, but it's a little better. A little piece that I wrote for the MIND project on the scientific method. If you read through, it's only a couple of pages long. It's not rocket surgery. But I want to discuss explicitly the argument structure involved in hypothesis testing, which lies at the heart of the scientific method. So I don't have a very pretty lecture note version of this. I do have something in Word, which I will lecture from. But something funky happened to my notes, and like big chunks of it just disappeared. So I'm only going to be able to go so far with this, and then I'm going to rely on this. So it's a multimedia presentation today. So let's go through this, and I can go through most of this pretty quick. So what I need to talk about now is the introduction to the scientific method. So one of the things explicitly that you should understand in a class on philosophy of science is what the nature of science is, and we'll be exploring that. In fact, that's one of our first issues, how to distinguish genuine science from pseudoscience. Another thing you ought to get is what's the purpose of science? Why do we rely on it? Well, two main reasons: to tell us what exists, and then to provide explanations for why the world is the way that it is. Now, whether something's an explanation or a prediction depends on whether the event to be explained occurred or not. If it has, it's an explanation. If it hasn't, then it's a prediction. But that's what science is in the business of doing. So what's the aim of science? To understand the nature of the world. And we rely on science to discover what exists, tell us what exists. That is, in the modern sense of philosophy, we tend not to think of philosophers as having a privileged position to tell us what exists in the universe, or why it's that way, or to explain why the world is the way that it is. Rather, we defer to science. That's what science is in the business of doing. And the reality is that there are many different kinds of science. The name of this course is Philosophy of the Natural Sciences. We have a similar course devoted to the philosophy of the social sciences, because social sciences are sciences, but they're what are considered to be the soft sciences. I've got some examples here of soft sciences: sociology, anthropology, economics, maybe linguistics. That is the social sciences. And part of your general education requirements are taking, if you're in the College of Liberal Arts, you got to take 12 hours in social sciences. That is, among political science, anthropology, sociology, and these others. And at least 6 of those hours have to be at the 2000 level or above, and you have to do it from at least 2 different social sciences. And within the College of Liberal Arts, there are a number of different social sciences. What we don't have within the College of Liberal Arts are any of the hard sciences, the physical sciences. In order to graduate from UNO, you need 9 hours in the hard sciences, in the physical sciences. At least 3 of those have to be in the biological sciences. And among the 9 hours, it has to be from 2 different sciences. Can you tell I've been dealing a lot with gen ed requirements lately? You know all of this, but you also know that there's a difference between the hard sciences and the soft sciences. So this includes physics, chemistry, biology, geology, astronomy, neuroscience, psychology. Well, it depends on the psychology. Neuropsychology, yes, that would be a hard science. Whereas Freudian psychology, in fact, that's right, as you'll discover, that's not even going to be a science, that's going to be a pseudoscience. The point is, there is a difference between the hard sciences and the soft sciences, and one of the questions we consider in a course in the philosophy of the natural sciences, which are going to be the hard ones, is why is it that they're better at providing explanations and predictions than the soft sciences are? And it's not really the scientific method, because we use the scientific method across all of the sciences, and we even use it in a sense in philosophy as well. But the basic idea is that there are different methods used in the different sciences. So we can draw a distinction between the soft sciences and the hard sciences, between the social sciences and the physical sciences. But what makes a science is in part that they must rely upon empirical methods in order to answer the questions that are driving the research or testing the hypothesis, right? In philosophy, well, we rely on arguments to settle issues. You can't settle a philosophical issue by conducting an experiment. If you can, then it's not a philosophical issue. That is, it's not a fundamental question. That's not to say that empirical data isn't relevant to philosophical issues. It is. There's no gainsaying that. But what makes a science is that it must rely on those methods in order to settle whatever the questions are. And to do that, they rely on methods. There are a whole bunch of methods So why study methods of research? Well, the bottom line is there's no one method that's going to answer all the questions that we want to answer in the various sciences. Even in the science involving the brain or the mind, there are all kinds of methods that we employ, and no one method is going to be able to answer all the questions. So there was a version of the philosophy of science class we used to have at UNO called the Methods of Science class, which was basically a survey of the different methods. I liked teaching that class, but it was hard getting students in it. So we're not going to spend as much time exploring the various methods so much as exploring various fundamental concepts related to the nature of science, like the nature of theories and how to distinguish genuine science from pseudoscience, and the nature of scientific explanation. There's a lot more stuff we could go into. In fact, this is definitely a subject worthy of a separate class. But the idea is that whenever you have a method, you've got certain assumptions that you need to make in order to be able to use the method. And this is going to come out today in our discussion about the scientific method generally. That is in hypothesis testing. And there's nothing wrong with that. In the same way that you can't have an argument without assumptions, you can't use methods in science without making assumptions. Assumptions by themselves are not bad things. So only someone who doesn't know what the hell an assumption is would say, well, that's just an assumption. In the same way that someone who doesn't know what the hell a theory is would say, well, that's just a theory. As if to say that is to call it a bad name. That's not the way it works, really. So I'm not troubled, and you shouldn't be troubled by the fact that you can't use any method in science without making assumptions. But as you've already seen, not all assumptions are equal, right? So when you dubiously assume the truth of something that's both unproven and unreasonable, well, that's a dubious assumption. And you're going to find that dubious assumptions are typically found, when you're using a method in a pseudoscience as opposed to a genuine science. There are all kinds of occasions when dubious assumptions crop up, but the idea is that something you already know here. You can't ask relevant and interesting questions without making assumptions. You can't make statements about the world that is claims without making assumptions. You can't assume statements as evidence in an argument to show that something's true without making assumptions. I'm probably beating a dead horse at this point, okay? Assumptions are not bad things. We'll be talking about them more. So you know that you can't ask questions without making assumptions, but like I said, you cannot make a claim, that is, an assertion about the way the world was, is, or will be, without explicitly and implicitly presupposing certain things about the world too. And you saw this when we were going through that material quickly in Chapter 3 about how to recognize arguments. You saw in Chapter 4 what the fallacies of presumption are, various ways in which an assumption can be rendered dubious. But the idea is that you can't make claims without making assumptions. So, for instance, if I were to report an observation, and this is what, among the kinds of things we do in science, is that we don't just sit in our blinds observing things. We record our observations in the forms of statement, right? So suppose I were to report something that I observed, that I once saw an elephant in Kenya. Which is true, I did once see an elephant in Kenya. In order for me to assert that, there are certain things I need to be assuming. That I exist, right? That I can see that Kenya exists, that Kenya's a place, that I've been there, that elephants existed at the time I went there, that it's possible for elephants to be in Kenya, and elephants are the kind of thing that's possible to see, that I was not blindfolded the entire time I was in Kenya, and so on. Now, I don't think we need to always identify these presuppositions when we make an assertion, but they're always going to be there. You can't make an assertion without presupposing certain things about the way the world is, or was, or whatever. In the same way that you can't ask a question to someone without presupposing certain things. There's nothing wrong with that. It's just that sometimes we need to make those presuppositions explicit, because not all assumptions, not all assumptions dubious, but not all assumptions are good ones. So you need sometimes to identify the dubious assumption in order to say precisely why someone's bit of reasoning is bad. So just accept the fact that there are occasions when sometimes you need to make explicit something that isn't explicit, that's implied, that's hidden, that's a presupposition as a part of your evaluation. So you saw some examples of this in the book, so I'm going to ignore that. What I want to focus on here ultimately has to do with this hypothesis testing in science and the logic underlying it, so that if you have any issues or problems with it, we can get that out of the way today. So I say modern science is predicated on the epistemological view called empiricism. Empiricism is an epistemological theory. Epistemology has to do with the nature and limits of knowledge. So, modern science is predicated on the theory of knowledge that the only way we have of gaining knowledge about the world is going to be through experience. That you're not born knowing anything, that you're not born with any ideas already in your mind. That's what empiricism is. So, tabula rasa is a phrase we get from the first of the three British empiricists, where he characterizes the mind as a blank slate when we're born. There are no ideas in our minds prior to our being born, that is, prior to experience. So everything that ultimately you know, every idea you have in your mind, you get there as a result of experience. That's the fundamental tenet of empiricism. So the only way we have of gaining knowledge about the world is going to be through experience, not through deduction, strictly speaking, like rationalists believe. In any event, we gain knowledge about the world through experience, that is from our observations, our perceptions, as well as the reports of observations of other people, because we all can't be everywhere. All right. Here's the thing. Nothing discovered through experience is guaranteed to be true. Let's pause there for a second. We haven't talked about the problem of induction, and I want to do that here for a second. Why is it that nothing that you learn through experience is guaranteed to be true?
You were imperfect in interpretation in the first place.
It's not guaranteed to be true because we're imperfect?
Well, not imperfect, but your faculties of learning things through experience are flawed. They do not. Your eyes don't record every single thing properly. Your brain.
All right. Well, how much is true? Give me an example of something that you've learned through experience. Express it in the form of a statement that you think is true. Really? We're going to use that one already? Yeah. That the sun will rise tomorrow. Okay, let's hold off on that one. Give me something else.
I wake up every day.
You wake up every day. All right. Why isn't that guaranteed to be true?
Because you may not go to sleep.
Well, I suppose in a trivial sense, well, you may not have gone to sleep, so there's no sense in which you've awakened, right? But what else could happen in the world such that would end up being false? What?
You could die.
Well, eventually that's going to happen. So sad, right? So there's going to be a morning when you don't wake up, right? What else could happen? The what?
You could be in a coma.
Not just a coma. You could be dreaming, right? That you're awake. That is, chances are you're awake right now, that you're not dreaming this particular experience, but it's possible that that's the case. And if it's possible, then it isn't guaranteed to be true. Even if it's very improbable, it's still possible that it's not the case. This is the reason why we typically use Hume's example here of the sun rising tomorrow. We've got lots and lots and lots and lots of evidence for the truth of the claim that the sun's going to rise tomorrow, but there's no guarantee. What could happen to make the sun will rise tomorrow false?
So you never saw someone crashing in the sun.
That's right. A big-ass asteroid. It'd have to be a big-ass asteroid. Big-ass asteroid destroys Earth, in which case there's no sunrise. A big-ass alien spaceship blows up Earth or the sun, in which case there's going to be no sunrise. Eventually there's going to be
far away from the sun.
The who?
Or this ship just moves us far away from the sun.
Moves us, that's right. Puts a tractor beam on us and moves us out of the way. Puts a big obstacle in front of the sun so that we don't see it get a sunrise. Point is, there are things that could happen, and eventually the sun's going to supernova, and there's going to be no more sunrise. There's going to be no more Earth. Point is, we've got about 5 billion years worth of evidence for the truth of the claim that the sun will rise tomorrow, but there's no guarantee. No guarantee. And it turns out, even if 1,000 black birds we call ravens happen to be black, right? Doesn't mean that the next raven we see is going to be black. That is, it's possible that there's going to be a white raven, right? So this is part of the point.
The raven won't be black on the basis that all the others.
Yeah, we didn't define raven as a black one, right? Just that it has certain
That's true.
physiological.
Right. It just happens to be the case that every raven we've seen is black.
And the sun won't rise tomorrow because it's risen every day.
If we were to make the claim that the sun's going to rise tomorrow on the basis of 5 billion years worth of evidence, then we have an argument. But there's no guarantee in that case. That is, even 5 billion years worth of evidence, which all things being equal is pretty good evidence, doesn't guarantee it. So this is the point. That when we're making a claim about the world, it's a contingent claim, which means it could be true, it could be false. Abraham Lincoln was the 16th president of the United States. Is that necessarily true? I mean, did it have to be that way? The answer is no. Is it possible that the history books were rewritten in the beginning part of the 20th century, and we're all just part of some, or dealing with the consequences of some big conspiracy, say, and it turns out that the 16th president was Biff Henderson, right? Not very likely, right? But still it's possible, in which case it isn't necessarily true. And this is something that shouldn't trouble you, but the idea is that anything that you would claim to learn on the basis of experience is a contingent truth, if it's true. Now, that means it's not necessarily true. So, contingent statements are the sort of statements that are either true or false. In order to show that a contingent statement is true, we need to offer evidence, like we would for an argument, right? And there's a problem here in that whether a contingent statement is true or false depends on whether what the statement asserts corresponds to the way the world is. If it does, it's true. If it doesn't, it's false. The problem is, how do we know? That is, it would be nice if there were a God's eye point of view that allowed us to be able to tell for sure which of the statements we now believe about the world are true. But there isn't. There is no, as Quine would say, cosmic exile. There's no privileged position in the universe that allows us to say, those are the true things we believe and those are the false things. Rather, we're limited to our experiences. And we can discover that something that we thought was true, we ended up being mistaken about. And this happens in science quite often, in fact. Kuhn's going to make quite a point about that. That's not such a bad thing. The point is, our statements about the world are never necessarily true, because necessary truths are statements that are impossible to be false, and our statements about the world are not like that at all. So we need to give reasons for the truth of our claim, and those reasons need to be relevant to the claim and independent of the claim, free of dubious assumption, and so on. And sometimes we can be mistaken, and that shouldn't be a problem either, but the idea is that science is predicated on the theory of knowledge called empiricism. And empiricism commits you to the notion that the only means we have of gaining knowledge about the world is going to be through experience, and that we're not born knowing anything. And that some things that we would now claim to know may turn out we're mistaken about on the basis of, or the accumulation of better evidence. We shouldn't be troubled by that. I'm going to skip that bit and get to here, because this ultimately is the main reason we're talking about this stuff today. So have any of you, I'd be surprised if the answer is no, but have any of you not heard about the scientific method before? I mean, how many of you have completed your physical science general education requirements? All right, did they talk about the scientific method in those classes? All right, good. They did, good, I'm delighted to hear that. So you're familiar with it, right? Well, one of the things that we're going to be covering in this class is the logic of explanation in science. And you may be surprised to hear that there really is a logic to explanation in science. Well, there's a logic to the scientific method as well. And since I've exposed you to, in a little baby way, to some fundamental concepts in logic, we'll make this explicit here. So here's the idea. When we use the scientific method, we use it to test hypotheses. What's a hypothesis?
When you're putting it in the scientific method, proving it or disproving it.
Maybe proving or disproving is too strong.
True or false.
That's not bad, right? It's what?
Educated guess.
A guess that does what?
Asserts how something might be.
Right, exactly right. There are all kinds of occasions when we might need a hypothesis in order to offer a tentative answer to a particular question or problem. But the idea is that, well, we need to test it. Forming hypotheses, well, there's no algorithm that we can employ in order to construct or generate hypotheses. But in terms of testing them, well, we can talk about the logical structure of that. So there's no algorithm for generating hypotheses. There's no hypothesis generator as such, but what we need to use is reason in order to form reasonable hypotheses that we can then test. So in the case of the material on the MIND project, the issue is, well, is the patient pregnant is the issue. So that's the question. And what you need to do is to choose a hypothesis. There are two options. Either she is pregnant, or the individual is pregnant, or the individual is not pregnant. So let's assume that our hypothesis is that the patient is pregnant. That's the hypothesis that we want to test. Now the thing is, and this is important, you can never test the hypothesis alone. Why? Because the hypothesis always carries with it certain assumptions. Whatever method you choose will always carry with it certain assumptions. So when you're testing a hypothesis, you're never testing just the hypothesis. You're also testing these, what are called auxiliary assumptions, in addition to the hypothesis. Does that make sense? Let's make this clear. So let's assume that is our hypothesis here is H. In fact, I'll write the structure of it on this other window. So H for us is that the patient is pregnant. Is that an argument by itself? It's an assertion. Is an assertion an argument? No, because in order to have an argument, you need both an assertion, that is a claim that something is the case, and one or more reasons given in order to show that it's true. So by itself, this isn't an argument, but it can be part of an argument. And it's not going to be the conclusion of the argument as such. That is, namely, I'm assuming that H is true. So I see, or what you see here is that, let's assume that H. I'm going to save myself some time and not write that out and just say 1. Let's assume that that's the case. That is, our hypothesis is that the patient's pregnant. Well, we need to test it. Well, in order to test it, we've got to choose a method. So in this case, let us opt for the blood test. That is a test measuring HCG in the blood. HCG is a hormone made when a woman's body, after an egg is fertilized and starts to grow into an embryo. Incidentally, HCG is also detected in urine pregnancy test, in case you didn't know that. So here's our hypothesis. The patient is pregnant. We've chosen a method in order to test it. Where are we now here in the structure of the argument? All right, so what do we write here? So this is the hypothesis we want to test. What else do we need to assume as a part of the test?
That HGC is a reliable indicator of pregnancy.
That is, there are going to be, I'm going to save myself a little time, a number of assumptions that we need to make about the particular method. That it's a reliable, that is, that we can use blood tests to test for that particular substance in the blood, or urine, the stream of urine, right? That there's going to be a certain set of assumptions that we're going to need to make using that particular method. So I'm just going to simplify things, and this isn't, logically speaking, the correct sort of notation for it, but there's going to be a set of assumptions we need to make in order to be able to use that particular method. So I'm assuming that the hypothesis is true, and I'm assuming that we can use blood in order to detect the presence of this particular hormone, and so on and so on, okay? Nothing problematic about that. I can make the structure explicit if we wanted to identify everything, but generally, in the same way that you can't make an assertion about the world without assuming certain things, you can't ask a question without assuming certain things, there are always those presuppositions. I'm just making that bit explicit here. All right, now, if our hypothesis is true and our auxiliary assumptions are right, what?
Then we'll see the HCG.
That is, what should we observe in the world? If this is the case, no, put it like this. If our hypothesis is true and our auxiliary assumptions are true, then what?
Then the patient's pregnant. And
No.
then you're going to get, I'm sorry. That,
No.
No. If the hypothesis is true, if she's, the hypothesis is the patient is the subject's pregnant. We have a set of assumptions and we have an experiment to tell H. So if that's all true, then we should be positive for HGC.
Right. So what we need to write here is a certain O statement, a certain observation statement. That is, if our hypothesis is true and our auxiliary assumptions are true, then we ought to observe such and such in the world. And what O is, let's say O is, we ought to detect the presence of this hormone in the blood. Agreed? All right. We perform the test. Well, there are two options. Either we do observe what we ought to observe if our hypothesis and auxiliary assumption is true, or we don't observe it. Let's deal with the negative case. We don't observe it. So our hypothesis is that the patient's pregnant. We're assuming a certain set of assumptions in order to be able to use the method, such that if our hypothesis and our auxiliary assumptions are true about this method, then we ought to observe the presence of this hormone in the blood after conducting the test. We perform the test. We do not observe the presence of that hormone in the blood. The question then is, what do we conclude?
Our hypothesis is net.
Or you can not trust your assumptions.
This is the point. It can't just be the hypothesis. Remember, it's the hypothesis and the auxiliary assumptions that we're assuming.
So that set of H and A is
One or the other is wrong.
We could do it this way, which, for the record, is going to be logically equivalent to this. Not H or not whatever those assumptions are. It's one or the other. We know something's wrong, right? Now let's pause here. Does this make sense?
Yeah.
All right. So the hypothesis is that statement. Right? We're not testing some state of affairs as such. We're testing the statement, right? And the statement's either true or false. So the statement is the patient's pregnant. That's our hypothesis. The patient's pregnant. Well, in order to use this particular method, we're assuming that the presence of this particular hormone in the bloodstream is a reliable indicator for pregnancy, so that if that's true and that's true, then what we ought to observe when we test this, that there's an increase or there is the presence of this hormone in the blood. There isn't. Therefore, what we conclude is that either our hypothesis is wrong or there's something wrong with our auxiliary assumptions. This tells us something conclusive and definitive. We know for sure that one of these things needs to be reevaluated. Does that make sense? And deductively, it's a little bit more complicated, but it has this particular form. If P, then Q, not Q, therefore not P. This argument form has a name. It's called modus tollens. So anytime you have an argument that consists of a conditional statement, the denial of the consequent, what follows, what you may infer, conclude, or deduce, is that the denial of the antecedent must be true. So in simplest terms, what we have is this. If our hypothesis is true, then we ought to observe the world in a certain way. We do not observe the world being a certain way. Therefore, we conclude that our hypothesis is false. Granted, this is too simplified, right? This is an issue for us because one of the people we're going to be reading here at the beginning of the semester is named Karl Popper. Karl Popper uses falsifiability as the measure of distinguishing between genuine science and pseudoscience. Genuine sciences are falsifiable. Pseudosciences aren't. Think about that for a second. If your theory, your hypothesis, whatever, is consistent with every possible state of affairs, then there's nothing you could ever experience that would show that your theory's wrong. Rather than that being a good thing, that's actually a bad thing. And Popper defends the notion that Freudian psychology, Adlerian psychology, are examples of pseudosciences. Marxist theory of history. It's possible that every state of affairs. That's going to be a bad thing. For him, the measure of the scientific status of a theory is its falsifiability and the riskiness of its predictions. There ought to be something that we could observe that would show that it's wrong. And that's what we have here in the negative case. And the reason why is because this is a valid argument form. It's impossible for the premises of this argument to be true and for the conclusion to be false. Impossible. Can never happen. So every substitution instance of this argument form is valid. And in the negative case, deductively, we know for sure that there's something wrong here. In reality, however, it's never the hypothesis alone. It's always going to be the hypothesis along with certain auxiliary assumptions. So when we don't observe the world the way our hypothesis and auxiliary assumptions would enable us to predict what we ought to observe, we know that there's something wrong, either with our hypothesis or our auxiliary assumptions. And since this A in braces, means that there's a set of assumptions that are actually being made. Well, you've got some work to do. You need to either rule this out or you need to rule these out. Okay, everyone clear here? So this case corresponds to the negative test, right? And this corresponds to an argument form called modus tollens. Modus tollens is a valid argument form. Validity is an important property of deductive arguments because every deductive argument is either valid or invalid. An argument is valid if and only if, just in case, when and only when, it is impossible for the premises to be true and for the claim to be false. Whenever that happens, whenever there's a necessary relation between the truth of the premises and the truth of the claim, and there are an infinite number of valid argument forms out there, whenever that happens, the argument's valid. And that's an important thing, because if you know that an argument's valid and the premises are true, it's impossible for the conclusion to be false. Impossible. Now, let's take a look at the positive case. So we have our hypothesis, and we have a certain set of auxiliary assumptions. And this leads to the prediction. If our hypothesis is true and our auxiliary assumptions are true, then we ought to observe the presence of this hormone in the blood when we conduct the test. We do. Therefore, what do we conclude?
Hypothesis is true.
H by itself?
H and
Now, this is the positive case. So if our hypothesis and our auxiliary assumptions are true, then we ought to observe the world being a certain way. We do. Therefore, our hypothesis is true. In fact, let's simplify it the way we just did it before. H, then O, O, therefore H. Now, what's wrong with this argument? It's not a valid argument. That is, it's possible for the premises to be true and for the conclusion to be false. That is, this looks similar to if P then Q, P, therefore Q. This argument form has a name too. This is called modus ponens. If P then Q, P therefore Q. Anytime you have a conditional and you have the antecedent of that conditional occurring on its own, you can conclude, deduce, or infer that the consequent of that conditional must be true. But this and this are not the same argument. This is not a substitution instance of this. This is a conditional. This is the consequent of the conditional. This is the antecedent of that conditional. First of all, do you all see the difference between these two arguments? This is an argument form, this is an argument, and this argument is not a substitution instance of this one. Do you all see that? Logic is all about form, pattern, or structure. So this argument is not a substitution of this one. This one's a valid argument form. This one isn't. And the reason why it isn't... The what? Well, the evidence isn't logically relevant to the claim, and the reason for that is that it's possible for the evidence or the premises to be true and for the claim to be false. So let's prove this to ourselves. In order for it to be possible, I'm going to focus on this argument here. This argument is a substitution instance of this argument form. If P then Q, Q, therefore P. In order for an argument to be valid, one way of fleshing this out is to say that in order for an argument to be valid, it must be a substitution instance of a valid argument form. So every valid argument is a substitution instance of a valid argument form, and every invalid argument is a substitution instance of an invalid argument form. Rather than having to prove the validity or invalidity of that infinite number of arguments in the world, let's talk about the forms themselves. So the argument we're considering here is a substitution instance of this form, which means that if it's valid, every substitution instance of it is valid. If it's invalid, every substitution instance of it is invalid. So let's ask ourselves, is this argument form valid or invalid? Well, in order for an argument form to be valid, it must be impossible for the premises to be true and for the claim to be false. Let's test it. In order for it to be possible, so I've got two parts here. I've got a P and I've got a Q. And every statement is either true or false. So the question is, I'm going to write the truth values over here for what must be the case over here. In order for it to be possible for each premise to be true and the conclusions false, what must the truth value of the conclusion be? All right, 2 people have said that. The conclusion is P, so P needs to be false. Again, I'm not concerned with the real truth values of the premises and the conclusion. In fact, these are statement forms. They have no truth values. Forms of statements don't have truth values. But again, here's the method. We're testing to see if it's possible for each premise to be true and the conclusion is false. In order for it to be possible for each premise to be true and the conclusion is false, well, the conclusion needs to be false. The conclusion is P, therefore P needs to be false. So P is false. If P is false here, then P has to be false here. You with me? All right, now, in order for it to be possible for each premise to be true and the conclusion is false, when the conclusion is false, what must the truth value of Q be? Q has to be true. And if Q is true here, Q has to be true here. So I've got an argument where the second premise is true, that is on the only possible way of making the premises true and the conclusion is false. P has to be false, Q has to be true. And here is the problem. I've run out of P's and Q's over here because P has to be false, Q has to be true. What's the truth value of a conditional when the antecedent's false and the consequence true? Class.
It's true.
And the answer is true. Remember, when we're talking about conditional statements, statements of the form if P then Q, the only way of making a conditional false is when the antecedent's true and the consequence false. When that's the case, the whole thing's false. But when the antecedent's true and the consequence true, the whole thing's true. When the antecedent's true and the antecedent's false and the consequence true, the whole thing's true. When the antecedent's false and the consequence false, the whole thing's true. The only way of making a conditional false is when the antecedent's true and the consequence false. You with me here? All right, so here's what this proves. This is an argument form where it's possible for the premises to be true and the conclusion false, which means that when the premises are true, there's no guarantee that the conclusion's true, which means that the truth of the claim does not follow from the truth of the premises, which means this is an invalid argument form, and every substitution instance of an invalid argument form is an invalid argument, which means that what we have here is an invalid argument. So here's the problem. The positive result doesn't result in something that is guaranteed to be true. The negative result does, because the negative result corresponds to modus tollens. That's a valid argument form. The positive case does not. And let me just tell you, while we're talking about this particular argument form here, that this argument form, if P then Q, Q therefore P, has a name. Does anyone know what it is? Affirming the consequent. Because Q is the consequent of this conditional. I'm affirming it in order to deduce the antecedent. Not only is it an invalid argument form, it has a name as an invalid argument form, namely affirming the consequent, which presents us with a bit of a problem. People tend, in the history of science, to consider positive results verifications of the hypothesis. And this is going to be a big issue for us, because it's going to turn out some people, like Popper, for instance, are vehemently opposed to the notion that what science ought to be doing is verifying hypotheses. And the reason is verification tells you nothing conclusive. Falsification does. Verification does not, particularly when verifications are easy to come by. And here's the problem that we were talking about earlier. How many sunrises guarantee that the sun will rise tomorrow? None. Now, you may have very probable evidence for the truth of a claim about the world, a contingent claim about the world. 99% of the times when someone jumps out of a plane without a parachute, they die. But is there guaranteed that you're going to die if you do that? No. I mean, you may be hoping that that doesn't happen. But is there a guarantee that you're going to incur a smoking-related disease if you smoke? No. And so on. I mean, think about it in a trivial case. Every single time you've left UNO to go home, your home's been there. Well, maybe not. In terms of Katrina, or maybe a hurricane or some other tornado or something. Here's the point. even though you've left your house 100 times, 1,000 times, and it's always been there, is it guaranteed to be there right now as you're sitting here in this class? Is the sun guaranteed to be up in the sky right now? If we went outside, we all held hands, went on the balcony, and looked up at the sky, and we saw that glowing orange orb, is it guaranteed to be up there right now?
I mean, if we were out there,
It really?
Probably die before we
Let's
get
do
up.
wait a second.
if we're observing it. I mean, it could
I'm
be-
glad you said that. I'm glad you said that. If we all, I'm not going to do it, right, because I'm being recorded, right? But if we walked outside right now, looked up in the sky and saw the sun, does that guarantee that the sun exists up in the sky?
It could have exploded
Why?
because light takes the.
So what you're looking at when you look up at the sun is actually light that's 8.3 minutes old. So you'll find out in a couple of minutes, right? But there's no guarantee. Even though we rely on the testimony of our senses all the time, and there's nothing unreasonable about that, the point is it doesn't give us guarantees. And the sense in which we're entitled to, justified, relying on observation is an issue we're going to consider. How indirect does an observation need to be before it's no longer reliable? For instance, without my glasses, I'm literally blind. I'm legally blind without my glasses. So when I take my glasses off, I see sort of blurry colors, right? If any of you were to commit a crime right now, I know where you're sitting. But you're all just a bunch of color patches to me. So for me to make an observation through vision, I have to rely upon this instrument. But the question is, how direct must an observation be before it's no longer reliable? So is the use of glasses still count as direct observation? A telescope, microscope, electron microscope? That is, we're observing something that we couldn't in principle observe without the aid of some instrument. And the issue is going to come up is how reliable are those observations? But in the end, that's all we have to go on. Again, science is predicated on the epistemological view called empiricism. We're not born knowing anything, so we have to rely on experience. All of our experiences come through the senses. Ultimately, that's the evidence we got. We can't go beyond that. There is no cosmic exile. So, in the case of hypothesis testing in science, there are two possibilities. There's the positive case, and there's the negative case. The negative case tells us something conclusive. Namely, if I can find it, that either there's something wrong with our hypothesis or there's something wrong with one of our auxiliary assumptions. That's deductively necessary. We know for sure that something's wrong here. The positive case, however, doesn't tell us anything conclusive. The positive case corresponds to what folks refer to as verification. And verification, even though lots and lots of people think, well, that just verifies my hypothesis, or that verifies this. At best, it's partial verification. It can never be conclusive. No amount of observations based on the past will ever guarantee that the future is going to unfold that way. That problem has a name. It's called the problem of induction. It's insurmountable. As Quine says, the Humean problem is the human problem. Hume's the one that introduced us to the problem of induction. So no amount of evidence based on the past will ever guarantee that the future is going to unfold that way. So the big issue for us isn't so much an issue between deduction and induction, because I can put the test in the form of deductive reasoning. And when we do so, this just makes it explicit that in the case of the positive test, again, this is valid. This ain't. There's no guarantee that this is true. Why? Because it's possible for the premises to be true and for the claim to be false.
Don't they just work around that by using the null hypothesis?
What do you mean by the null hypothesis?
So when you're testing a hypothesis, you're not testing for the hypothesis. You're testing for the null hypothesis, that your hypothesis is not true. That's what they taught me in statistics. You either accept or reject the null hypothesis.
Yeah, well, that works okay for statistics, but the problem with statistics is that statistics can be made to say anything.
Yeah.
Right? In the same way that, I'll show you this point. I made this point in my other logic class. Suppose I'm assuming the truth of P as a premise, and I'm assuming the truth of not P as a premise. What follows from this?
You're assuming a contradiction.
Well, I'm assuming a contradiction. That's the case. But what would be the conclusion of a valid argument with this and this as a premise? Anything in the universe. That is, anything follows from a contradiction. So The null hypothesis may be a bit too technical and it applies in certain methods. But generally speaking, I would say that there are two possibilities when it comes to hypothesis testing. There's the positive case and there's the negative case. The negative case corresponds to falsification, which is what Popper's going to be defending as a solution to the problem of demarcation. That is the problem of distinguishing genuine science from pseudoscience. Verification doesn't tell us anything, but verification comes up in this class because the principle of verification was the principle of a very important and influential movement in analytic philosophy called logical positivism. And logical positivists were concerned with a number of things, but mainly the meaningfulness of our statements about the world. And in order for a statement to be meaningful, there needed to be something we could observe about the world, largely construed, in order to show that it's false. If a statement couldn't be verified in principle, then it was, from their perspective, metaphysically meaningless, literally senseless, had no meaning. And it turns out, from their perspective, lots of statements in the history of philosophy end up they pass for statements, but they end up being literally meaningless. So one of Carnap's big opponents would be someone like Heidegger, for instance. Heidegger says something like, the nothing noths. Now, what could you possibly observe in the world that's going to show that that statement's true? Right? For Heidegger, well, it had a meaning, but it has a meaning in relation to a larger system, and he's not assuming the principles of empiricism. I mean, there are some genuine issues here. In fact, there's a nice piece that that Carnap wrote against metaphysics, and he's primarily attacking Heidegger as representative of a particular style of philosophy where they make utterances that have the appearance of meaningful statements that turn out to be literally meaningless and senseless. Now, our concern with the logical positivist is going to have to do with explanation in science, not so much questions about meaning and whatnot. But this is going to be an issue that's going to come up. I'm just letting you know here at the get-go that there is a logical structure to hypothesis testing in science. And a little bit of logic goes a long way. And sort of understanding the fundamental difference between verification versus falsification, because we're going to be dealing with that next week. Now, do you have any questions for me? We've covered quite a bit of ground today.
I just want to say, you taught that stuff way better than the discrete math teachers over there in the math department.
Well, thank you.
But it's a damn.